didn't know what to do with 3.
Okay, we're doing number 29. I keep walking on this. We're doing number 29, which is an equation which we all need to be able to solve. V squared minus 5 equals 8 minus 2v squared. That problem, Katie?
Yep.
All right, how did you start it? You said you could get it started.
Well, I added 2v to v squared.
Okay.
And then
So she brought her, I want everybody paying attention, she brought her 2v over here, so you had 3v squared?
Yeah.
All right, then what did you do?
And then I added 8 over to 5. Subtracted 8 over to 5.
Okay, got it set equal to 0, in other words, which is what we generally do with our quadratic equations. Okay.
Then I got stuck with the 3. And then I didn't really add it.
Okay, now, she's got a couple of different options here, doesn't she? Let's remember, anytime it's a squared equation, a quadratic, you can use the quadratic formula. Let's never, ever again get stuck at this point. Now, I'm not saying it's the best way to do this particular problem, but it will always work. So A would be 3. What would B be? 0. And C would be -13. So if you want to do the quadratic formula, you can. Now, Jack, you were going to raise your hand. Did you have another thought on this problem?
No, I just thought I did wrong on it.
Okay. So, a different strategy that doesn't work all the time, but it works whenever you're missing that middle term, is to move the 13 back over, Katie. I'm not trying to confuse you, I'm just giving you another option. You move the 13 back over, divide by 3, and then you can square root.
Yep, that is what I did.
So that is an option.
That's the answer?
Well, we have to clean that up because we're not allowed to have a radical in the bottom. So we'll have plus or minus root 13 over 3 because we got the square root of 13 over the square root of 3. And then do you remember what to do when you have a radical in the bottom? It's not
Move it to the top.
well, so you multiply top and bottom by root 3. And then what's root 3 times root 3? Just 3. And then the top would be plus or minus root 13 times 3.
So you could only do that when you're missing the middle term?
Yes.
Okay.
Now, if that's going to confuse you, I really don't want to add to anybody's confusion. Remember, whenever you have a squared equation, you can always use the quadratic formula. Get it set equal to 0 and use the quadratic formula. Okay? All right, Jabron?
Number 18.
18?
Miss Ford,
Yeah.
if we ever want to test, like, do a problem, like, wrong, like, get the wrong answer, but the way we did it is right, will we get partial credit?
Oh, absolutely. Wait till you get your test back, and I'll give it back as soon as everybody's taken it, but you'll see. Minus, if you make an arithmetic mistake, it's minus an 8. Okay? So,
I have another question on that. I got to hear this, is sometimes I get to hear, and I get this answer when I do
your
that.
flower is shedding.
Oh, sorry. But do you take the 6 out of?
No, you break down to 156. You do your tree thing. Remember what we're talking about?
Yeah.
Yeah. So what is that now? No. I think she needs to bring it in the next box.
I'll bring you, like, a whole pack.
I'll bring you like a bunch of them if I could just have that homework. Please.
You just don't eat them.
And cookies.
No, that's literally the one night I don't do my homework.
I'm not going to email your parents for one day.
Yeah.
Can I like just use your peanut box for that?
It's number 19, Jabron. 18, explain why the percentages cannot continue indefinitely to follow the linear models that you wrote in exercise 15. Okay, yeah. Here's the deal. When you draw a line, let's forget about the equation, period. When you draw the line, yesterday we talked about how for the men, their employment was decreasing. Remember that yesterday? So if I draw my line, it's going to be a decreasing line. So it's going to look something like that, correct? Now, the question is, how do you know this line's not gonna go forever and ever and ever? Well, what happens at this point right here? How many men are working at this point? 0, right? We don't have any men working. Look at these down here. Can we have negative men working? No. So what they're trying to get you to understand is that algebra doesn't always fit the real life because you can't have negative numbers, or sometimes you can't have zeros and stuff like that. So they're simply saying, explain why that's true. Well, the line goes on forever and ever. The reality is I can't have negative values. So I would be only looking at the part of the line that was positive. Now for the women, that line was actually increasing, wasn't it?
Yeah.
Okay, so it's gonna look like this, something like this. Now tell me about this. Can that just keep going forever and ever and ever? No, because if every woman in the world worked, that'd be 100%, right? Can I go any higher than 100%? No. So the women have that kind of 100% boundary and the men have that 0 boundary. Make sense? Yeah. So don't make a bigger deal of that than it was. That's kind of what you were doing. Katie?
Could you do 32?
Okay, 32 is another equation.
Yeah.
Okay, Veronica, I'm gonna need your help here. I think you helped me yesterday with this thing, with something like this. Can't remember. What's wrong with this equation, Veronica? Got fractions. And I don't like to do my problems with fractions. Could I do my problem with a fraction? Yes, but I don't want to. So, I sound like a spoiled rotten brat. I don't want to. So what am I going to do, Veronica, to get rid of that fraction? I'm going to multiply everything by 4. So when I do that, I'm multiplying everything by 4. Maya Brownlow, what's my equation going to look like after I times it all by 4?
See, Ms. Moore, I was gonna help you the last part. Did you see me like trying to raise my hand? 4x squared minus 28x minus 12. Wait, 12 over 4.
Which is? 12 over 4? 3. See, that's the beauty of it, Maya. When you take this times 4, those are going to cancel. And all you're going to be left with is the 3. Katie Baumgartner, what kind of an equation is that?
It's a quadratic.
So what am I going to do with a quadratic equation?
A equals 4, B equals negative 28, and C equals negative 3.
And then I'm going to plug it into my quadratic formula, and I'm going to get the answer.
And when it's like a negative for B, it's a positive.
And I have no idea what 28 squared is, so I'll do that on my calculator. Okay, tomorrow we're going to have a quizzy poo, folks. And I'm going to ask you to solve a couple of these tricky equations, so I hope you're paying attention. Tomorrow.
Okay.
And it's like
I need my
these.
points after that.
So I hope you're paying attention.
And it's like these.
It's going to be tricky equations, just like these. All right, so I still need my calculator, yes.
I'm going to do it on this quiz tomorrow.
Okay, I'm the teacher. I probably shouldn't be the only one typing all this into my calculator. Should probably have some audience participation here.
Maya, put your hand down. We can't answer all the questions.
What would I do with my 832 now?
Break it down. Break it.
I'm going to break it down. Yeah. And that's a big number, so that's going to take some room probably. I can see it breaks down by 8. So 832 is 8 times 104. That's 2, 2, and 2. And 2 times 52. 2 times 26, 2 times 13. There we go. So I've got 2 2s, 2 2s, 2 2s,
6, 8.
8 root 13? Yeah.
Over 8. Divide by 4.
Exactly. Be careful. Don't just cancel out these 8s. You have to look at your triangle here. And all I can take out is a 4. So I'll have 7 plus or minus 2 root 13 over 2. There are your answers, kids. Okay, now listen. I don't know what confused you about that problem to start with, but we got to get rid of the fractions.
Yeah, it was really just a fraction.
And then just use your quadratic formula. What?
What did you divide? Why did you divide by 8? Oh, I see. Never mind. I just
I take a 4 out of there. All right, let's find our note sheet.
The new one or the old one?
This one, actually, on the very last page of the old one.
What new one? Yeah, here it is.
Let's not joke about that. Okay, this is really important stuff. I don't think it's new to you, but it's really important stuff. So we are looking on the back side of note sheet 8 at section 1.2. Which are functions? Now, in order to do that, the back side of 8. All right, here we go. Which are functions? How do we tell? Ethan Topham?
If the lines go over one another again on the vertical line, then they are not.
Exactly, vertical line test. So take that first picture, and you can do it, go to the back side of that. No, the back side. If you draw a vertical line down through that V, no matter where you draw your vertical line, it will only hit the V one time, right? Each vertical line only hits one time. That means it is a function. So look at the second picture, B.
No.
What happens if you draw a vertical line through that shape? How many times does it hit? Twice. Not a function. A is, B is not. What about C?
Yes.
It is. What about D?
No.
No. E. Yes. And F. No. Are we okay? F is not a function.
But, for E,
It's not a triangle.
or is that just B?
I can only like this.
Yes.
D is a no.
Oh, yeah.
D is no, kids, because if you pass a vertical line down through it, you're going to hit twice. And the vertical line test says you can only hit once, right? Now, this next section is huge. Domain. Can anybody tell me what domain even is? Maya? All the X's. In other words, when I look at question A, and it says, find the domain. What I want to know is, which X values could I plug into this function? Remember, this is the same as y equals x squared plus 5. F of x is the same as y. You can switch them out. If I were going to set up a t-chart so that I could graph this thing, plot some points and graph it, what x's would I be allowed to put here? That's my domain.
0, -1, 1.
Okay, somebody picked 0, -1, and 1. Could I pick any other numbers, or are those are the only numbers?
Any number.
I could pick what? Somebody said it.
Any number.
Any numbers. The domain for this function is the set of all real numbers. And the symbol for that is this. This is the symbol for all real numbers. If the symbol's gonna freak you out, just write all real numbers.
Could you go over the order numbers? Just all of them.
Now, here is what I want you to think about. Anytime, and this is, please write this down. Anytime someone asks you a domain question, the answer always starts out as all real numbers. But there are two things that can mess that up. There are only two things you have to worry about with domain. The two things that mess up domain are fractions and radicals. So if you have a fraction in your problem, you're going to have an issue. And the issue is because the denominator cannot equal 0, ever. In a fraction, the denominator can never equal 0. So if you have a problem with a fraction in it, you got to pay attention to this. The other issue is with a radical. And with a radical, whatever is under here has to be greater than or equal to 0. In other words, whatever is under the radical has to be positive. Because what happens if it's not? You're imaginary, and we don't want to be imaginary. We want to keep it real. So we are going to make sure that whatever is under the radical is positive. Jabron? Jabron, I will move you if I have to. All right? And that's like a third grade thing. I really don't want to do that, but I need you not to distract the girls. Maya?
Okay. I'm still on the denominator part. I'm not.
Let me do some examples, okay? What I want you to write down right now is that if you look at your problem, like this one, this was our first problem, right here. Does this problem have a fraction in it? Is it a fraction? No. Does it have a radical in it? Therefore, it doesn't have, these are the issues, these are the problems. This one doesn't have either one of those problems, so its domain is going to be all real numbers. Any problem that doesn't have these issues, no fraction, no radical, no issue, all real numbers, okay? Now, when I look at question B does have a radical in it. So when I find the domain of question B, I've got to pay attention to this rule because it has a radical. So what is the rule for a problem with a radical in it? Whatever is under the radical has to be greater than or equal to 0. So what's under the radical? 5. Well, no, x plus 5. This has to be bigger than or equal to 0. So I'm going to solve this. So x has to be bigger than or equal to -5. That's your domain. Your domain is all of the x's, this is for problem B, all of the x's greater than or equal to -5. How did I know that? Well, the problem had a radical, and I'm going to know these rules. When there's a radical, whatever is underneath the radical has to be bigger than or equal to 0. And then you just solve that, and that's your domain. Now, look at the next one. The next problem has a fraction in it. Okay? Now wait a minute. It's got a fraction in it. That's a problem. What do I know about fraction problems? The denominator, what's my denominator? X plus 5 cannot be 0. You can never let the denominator be 0. So if I subtract 5, x cannot be 5. -5, sorry. X can't be -5. Just solve this equation. Subtract 5 from both sides. X can't be -5. So what is the domain for this problem? The domain is x can't be -5. X can be absolutely anything else, but it can't be -5.
So the answer is x cannot equal -5.
That's the domain. Yep, it says what's the domain? That's the domain. All right, let's look at the next one. By the way, does this letter matter?
No.
It's just the name of the function. Like we all have different names. These functions all have different names. P of x. And is f of x same as y? Now, when you are asked a domain question, here are the two things I want you to ask yourself. Is there a fraction? Is there a radical? So look at this problem. Is there a fraction?
Yeah.
Yes, so I'm going to worry about this. Is there a radical?
Yeah.
In this problem, is there a radical? No, so I don't need to worry about this. This is the only one I need to worry about. And what's the rule when you have a problem with a fraction? Denominator cannot be 0. Then I just solve that. So 4x can't be 1, and x cannot be 1/4. That's your domain. That means that x can be any number you want it to be, except 1/4. Got it? Pretty easy. All right, let's look at the next one. E. Okay. No radical, but I do have a fraction, right? So what do I know about fractions? Denominator cannot be 0. So now I'm going to solve this. Uh-oh. Does this bother anybody?
Yes.
What's bothering you?
It's gonna be
It's going to have an I. That means, can this ever equal 0 in real number land? No. So what's my domain? No issues. It's all real numbers.
Oh.
I can't have an I answer. If you're getting an I answer, then that means you don't have any worries, because that's not possible. Here's what I really want you to think about. It's a little confusing, I get it, but just think for a second. Stop talking, stop writing, just think. 3x squared plus 1. 3x 3x squared plus 1. Can that ever be 0? Think about it now. Won't 3x squared be positive?
Yes.
And if you add 1 to it, isn't it still going to be positive?
Yes.
Can it ever be 0 then?
No.
No, which means you can put in anything you want. The domain is all real numbers. Because there's nothing that will make the denominator 0. Impossible. Maya?
Negatives are covered by real numbers, aren't they?
Negatives are real numbers, yes. Anything without an I, so even like the square root of 10 is a real number.
So if you solve and you get an I, it's real.
Yep,
Okay.
yep,
Simple as that.
because that means it's not possible to have a problem.
You don't have to worry about the top part of the fraction.
Nope. Well, not for domain, you don't.
Yeah, yeah.
Right, for other things we will. Okay, let's look at F. Come on, let's see if we can get through these. Yeah, you're gonna say 3x cannot be 0, which means x cannot be 0. If you divide both sides by 3, x cannot be 0. So Katie says the domain to question F is anything except 0. X can't be 0. How about the next one? It's a little bit harder.
Is that just the answer?
That's the answer.
But you have to square root the next one.
Uh-huh, we're gonna have to do some square rooting here because we have a fraction again. And we know that the denominator cannot, the denominator cannot be 0, right? Which means x squared cannot be 9. So x can't be plus or minus 3. Remember, when you take the square root, you have to do plus or minus. Uh-oh. Look at H. Double trouble. Because H
I'm gonna say avoid trouble.
has a radical and a fraction. So you have two things to worry about. What's the radical rule? Whatever is underneath 5 plus x has to be greater than or equal to 0. The radical rule, Katie Thomas, is whatever is under the radical has to be greater than or equal to 0. So I'm going to say 5 plus x is greater than or equal to 0. And I'm going to solve that by subtracting 5. So what's x? Greater than or equal to negative 5. Part 1. Now, what's part 2? Denominator cannot be 0?
Yep.
Which means x cannot be 2. So this problem has a two-part answer. X has to be bigger than or equal to negative 5, and x can't be 2.
So we don't have to worry about the top when it has
A radical.
Okay.
Yeah. You always worry about radicals. You always worry about denominators. Okay, I.
This one's kind of tricky.
What do I have to worry about in question I? I have a radical. Yeah, you're ahead of this, Brooke. You're right. I have a radical, and whatever is under the radical has to be bigger than or equal to 0. Now, Brooke is ahead of us here. Pay attention. When you solve this, you get negative x greater than or equal to negative 2.
You have to switch.
When you divide, you got to switch the sign. So your domain is x is less than or equal to 2. The rules are the same for dividing by negatives. That doesn't change. When you divide by negative, you got to flip the sign. And the last one,
It's not possible. Greater than or equal to 0.
3x plus 1 has to be greater than or equal to 0. So when I solve that, x has to be greater than or equal to negative 1/3. Paige, we don't bother Brian. He's,
Wait, why is that one possible and the E wasn't when it was a
because I
fraction?
took the square root, I can't take the
Oh, so you can solve a fraction.
Yeah.
When there was the x squared, it was
Okay, so tomorrow we're gonna have a quiz. The quiz is going to have a couple of complicated equations on it, like we practiced in our homework last night, those of us that did our homework. The next day, I might give another quiz about domain. I won't give it tomorrow, but soon we're gonna have a domain quiz. And what are the two things you have to remember about domain? You can have the denominator equal 0. So you say denominator can't equal 0. Whatever is under the radical has to be bigger than or equal to 0, right? Okay, we're not done. Don't pack up. We got stuff to do.
So why on J is it okay for it to be there but not on E?
Because in E we were square rooting the solve for x. We are not square rooting in J. Negative numbers are fine, because square roots of negative numbers are not fine.
And if it's not fine, it's all
Just make sure you memorize.
I think you're okay.
Solve it quick. Now, number 3, part 3, we gotta get going here. Find the vertical asymptotes and graph them. Now, vertical asymptotes. That's quite a mouthful. What am I talking about when I say vertical asymptotes?
I think I have an idea.
Yes, Jabron.
Is that the points where it falls on the y-axis?
Those actually would be the y-intercepts,
Okay.
which are going to be an important part of our graph too. But right now we're doing just vertical asymptotes.
I'm gonna stay over here then.
Now, tell me about the domain of this problem right here.
They can't.
X can't equal 1. That, boys and girls, is your vertical asymptote. So where x equals 1, you draw a vertical line and say my asymptote is at x equals 1. Because what happens to my problem if I put 1 in for the x? Look at it. You get a 0 in the bottom, and that is never allowed. So we talked about it in terms of domain. Now graphically what that means, graphically it means you have a vertical asymptote there. Whatever makes the denominator 0 is going to give you a vertical asymptote, period. So when I look at question number B, what would make that denominator 0? Now it's going to be a fraction, so don't panic. What would make that denominator 0?
5/3.
5/3. So guess where my vertical asymptote is, kids? X equals 5/3. Now, how did I know to put it there? Because 5/3 is 1 and 2/3,
Yes.
which is between 1 and 2. Where do my vertical asymptotes come from? Whatever makes the denominator 0. Your denominator's never allowed to be 0. Not allowed to be 0. Graphically, that's a vertical asymptote. How about C?
It's not a point.
You get 2 answers. What are the 2 numbers that would make the denominator 0?
2, -2.
Exactly, Jabron. So guess what? We're going to have a vertical asymptote at x equals 2, and we're going to have another one at x equals -2. Why is that? Because my denominator X squared minus 4 cannot be 0. So x squared cannot be 4, and x cannot be plus or minus 2. Those are your vertical asymptotes. Vertical asymptotes and domain go together. Vertical asymptotes are just a picture of the domain. When you say, Mrs. Ford, x can't be 2, I say that means there's a vertical asymptote of 2. Next side. What are you going to do with D?
Wait, we don't have to.
Wait, so when it's negative,
Oh,
positive,
your next side, you have your new note sheet. We're moving on to the new note sheet.
That's fine.
What? Yeah, you can factor it. I'm going to give you factoring problem, so you're going to factor. Okay, so we're on our next note sheet. Sorry about that, I made a transition.
So when you get 2 answers, you line the 2. Like you make.
Yeah, you have 2 lines, yeah. So look at D. How do you think we're going to start D, peeps?
Set it x equals to 0.
Quadratic. Well, we could use the quadratic formula. This will also factor. So let's see if we can factor it. I'm going to give you easy factoring problems, so let's see if this will factor for us. X squared minus 4x minus 5.
I know what this is.
Okay, Jerron.
-5, +1.
You are exactly right. Now be careful though. Where does that mean my asymptotes will be?
I don't know. Negative.
Exactly, at 5. And you have to graph them, so please put a vertical line at 5 and a vertical line at -1. Those are your asymptotes. Now, do I worry about the numerator of the fraction? No, it's just like domain. All we care about is denominator can't be 0. Right? How about E?
Almost the same way.
Could you do A, B, and C?
X minus
What?
Could you do like the A, B, and C?
You could. Now, I need, oh, shoot. We need to start with E tomorrow, because E is a trick problem. We'll start there tomorrow. Do you have homework? Do it.
Homework unless.
You have to turn in what's due and assigned for the day that you're asking. You are taking your test. Who do I email, Mrs. Ressler?
Yes, please.
Still here?
Compose to Vicki Ressler and Anna Lynn Hauk, Schmuddy. Is with me period 3 today. send. Okay. Yep. This is homework you're turning in?
Yep.
And now you need a test.
Can I use a notebook to write on?
Uh-huh. Okay, so this is all of your review work.
Mm-hmm.
Now, let's see, though. Let's see. Oh, yeah, that would take care of all of your absences too. Except, you missed the Friday before. Remember that on here. So you need to assign on August 26th.
Do the homework assignment for that day.
What's going on?
This is my 18th birthday,
It's
and
his
this is my
birthday today.
procession.
It's what?
It's his 18th birthday
Do you
today.
by any chance want some Cheesecake Factory cheesecake?
Happy birthday.
There's lots of people. Did people give you this or you brought it?
I brought the cheesecake.
I would love a piece of cheesecake.
There's also strawberries and whipped cream if you want that.
Oh my gosh, no whipped cream, I love strawberries. Okay, I even got some plates, how about that?
So the thing good.
Do you need plates?
Yeah, you can take some fudge.
Fudge. Oh god, where's that fudge?
It's right there.
Oh lord.
Nelson's like, that's what I'm getting right there.
That.
You okay now?
I need to get Bruce test here. That looks so good. Today's your actual birthday?
It is.
Happy birthday.
Thanks.
Oh my
Yeah.
It makes
There you
sense.
go.
Thank you.
I have plates.
You do have plates? Oh, I have I got forks.
There we go.
We'll have to write up the
Oh my gosh, this looks so good. And you bought this though, you didn't make it?
Yeah, I did buy this. I did make the pumpkin fudge though.
Pumpkin fudge, never heard of that before. Is it quality? Oh, this is gonna be so many hours on the elliptical that I don't even care. This looks so great. What do these have on them?
It's just a strawberry glaze.
Oh my gosh. Oh my gosh. And pumpkin fudge.
Mm-hmm.
Where's that?
Right here.
So this is actual fudge made with pumpkin?
Yeah.
Oh my gosh. This is so many calories.
What does fudge have in it?
Pumpkin pecan. It's my personal favorite, so I like it enough that I made it for myself.
Uh-huh. Mm-hmm. Might need that recipe.
I can give it to you.
Well, happy birthday, Andrew. Wish you had more of them. Really good.
Mrs. Ford, can I go to guidance for real quick?
Well, the bell hasn't even rung yet.
know what? Here I'm eating my cheesecake, I think it's all on video.